To master Python, you must understand the difference between references and copies. With a reference, any change you make will directly modify the original object. Look at this list here. It is assigned to our first variable. This is variable A. Now we create a second variable, variable B, and we set it equal to the first one. This is a reference. Variable B is now pointing directly to variable A. So when you add an item to the second variable, it is automatically added to the first one too. Running this code, you will see that as soon as I add this fourth item and print the results for both variables, they both show 4 items instead of the original 3. They are linked. But what if you want a true copy to act as a secure backup? Imagine you have today's customer orders, and you want a safety snapshot of that data. At the end of the day, say 6 p.m., you decide to back everything up. To do this correctly, take your first variable and call the .copy method on it. This physically duplicates the objects in your memory, creating a completely independent version. Now, when you add a fourth order to the list, it only appears in your backup copy. The original remains safe, clean, and unmodified. This is perfect for testing new ideas without breaking your primary data. It gives you total control over your experiments. Always remember, simple assignment just points back to the same source. It is just a shortcut. But with the copy method, you are building an entirely new physical list. Both variables now operate independently, handling their own separate data. In other languages, we call these reference types versus value types. One shares the data, the other duplicates it. Master this, and you will write much safer Python code. Python, like life, can be full of surprises. Ever look at code and wonder what's happening? You stare at it, completely lost. You look at this and think, what's the catch? Usually, it's because the fundamentals aren't quite clicking yet, but mastering the basics is your ultimate key to success. Take the copy method. It creates a true physical duplicate of your data. When you use it on a list, it grabs every item and creates what we call a hard copy. Running this, you'll see that in our original list, which we're printing now. Jamie, Robert, and Susan are all there. But look at the copy list. Only Robert and Susan remain. In this version, Jamie has been removed. This is a completely separate physical copy. It is not just a reference to the original. If you remove the copy method, both variables point to the same data. Now, when you delete Jamie, you'll notice he vanishes from both the old list and the new one. So, looking at this next block, the list constructor, what's the goal here? What do you think happens to the original when we remove Jamie now? Surprise, Jamie is missing only from the new copy list. This happens because the list constructor in Python accepts a list and automatically generates a physical copy for you. Instead of manually calling the copy method like before, the constructor handles that duplication behind the scenes. So why use the constructor at all? Doesn't it seem a bit redundant? It can be confusing. The copy method shows much clearer intent. Usually you want your code to scream exactly what it's doing. I want to copy this. Using the constructor here looks like converting a list into a list. It's a bit odd, but stick with me. It works. And there's a huge benefit to this. What do you see in this next example? The same names, but look closer. This time we're using a tuple. Tuples are wrapped in these round brackets instead of square ones. We're using that same list constructor to process our users and remove Jamie. Taking Jamie out leaves Robert and Susan. Now, watch the magic happen. The original users list still has Jamie, Robert, and Susan, but our new copy has only Robert and Susan. It didn't just copy, it transformed. It converted a tuple into a list and created a hard copy at the same time. You can already see why this is powerful. The list constructor can take many different data types and turn them into lists while keeping the original safe. You might wonder, can't I just use the copy method on a tuple? Actually, no. Tuples don't have a copy method. If you try it, your code will crash. Tuple object has no attribute copy. The method simply doesn't exist there. That's why this constructor is so versatile. It allows us to duplicate and convert data in one clean step. This is a game changer when you're pulling varied data types from all across the web using different APIs. As a newcomer, Python's flexibility might actually surprise you. Looking at this code, you might feel a bit lost in the details. Don't let the fear of missing out get to you just because of the syntax. Let me break it down for you with the full context. As you know, the copy method creates a completely separate version of your list. Imagine a list with 3 names, Jamie, Robert, and Susan. If we create a copy and remove Jamie from it, the original list remains untouched. See, the original still has Jamie, Robert, and Susan, but in our copy, Jamie is gone. The List Constructor method works exactly the same way. It builds a fresh physical copy. Now, let's try something new. Instead of names, let's use something we all love, computers. Here is a list of computer peripherals, laptop, mouse, and keyboard. We are capturing a physical snapshot of this inventory right now as we run the code. I've been using this method throughout the entire session. We'll focus on this one specific option for now. And before we continue, thank you so much for your support. Now, this next part might look a little strange. In our first inventory snapshot, we only want to include the laptop and the mouse. Python is 0 indexed, meaning we start counting from position 0. So we have position 0, position 1, and position 2. Position 2 corresponds to the keyboard. The slicing syntax is clever. It stops exactly 1 index before the number you provide. It takes position 0 and 1, laptop and mouse, but skips the keyboard. If I change this index to 1, what do you think the result will be? Think about it for a second. I know you have an idea. Since 0 is the start and we stop before 1, we only expect the laptop. Let's run the code and see. There it is, only the laptop was copied. This still creates a physical copy, but it gives you the power to select specific parts. While the other methods copy everything, slicing lets you pick your starting point. If we start at position 1, we grab the mouse instead. And as you can see, the mouse is copied. You can tweak and change this slicing notation however you like to fit your needs. Mastering Python requires a rock-solid foundation. These fundamental concepts are the key to your success. Take a look at this code. It looks simple, but the logic is quite deep. Gaining a true understanding of this is absolutely essential. Can you spot what is happening? What are we looking at here? This is a nested list. We start with an outer list. Notice the yellow brackets. These are our square brackets. Inside, we have additional lists nested within. This represents the first item of our outer list. And here's the second item in that same list. But look closer. You have the first and second items, living inside that inner list structure. Now that you see the structure, you are well on your way to becoming a pro. What do you think the copy method does? Any guesses? Give it a thought. Think carefully about how Python handles this. This copy method will create a duplicate of the list. If we modify an item inside our copied list variable, what will the result be? Will the original list change too? When we print both the original and the copy, do you think the first list will be affected? What is your verdict? Running the code shows the original was amended. The original prints first, followed by the copy. Both have been changed. This is because the copy method only duplicates the outer list. It does not create new copies of the internal items. In memory, it still points to those original inner items despite making a copy. You just discovered something vital. This is how you avoid bugs. So, how do we fix it? It is very simple. We use the same code, but this time we import the copy module. This module features a specific method called deep copy. We will create a deep copy variable. We pass in our original list, just like we did before. Now, when we modify the first item of the list, specifically that first internal element, look at what happens when we run the script. We now have 2 entirely distinct copies. The original remains untouched. Always use deep copy to create a true independent version of your data. Deep copy iterates through every level to ensure every item is physically duplicated. I hope you found this incredibly useful. It is the best way to prevent bugs in nested lists. Check out my other videos on reference and value types. They will help you level up and become an exceptional Python developer. You won't want to miss them. Let's elevate your Python skills to levels you never thought possible. Learning here is incredibly effective because we dive into the details that most others overlook. We are going deep into the Python world to uncover some truly powerful tools. I have previously touched on the deep copy. You likely know how it works, but if not, here's a very quick refresher. Deep copy creates physical duplicates of your nested lists, basically lists within lists. That is the essence of deep copy. Standard list methods often fall short with these complex structures. Usually, you would import the copy module, and then use deep repeat to handle those nested lists correctly. But there's a better way, using list comprehension. This allows you to map data into a new list directly. With nested lists, the logic looks like this. The syntax might look intense, but look closely at the logic. Essentially, we are building a new copy, row by row from the original source, iterating through every row within the data. There is your variable. To handle the nested structure, we go one level deeper. We add another bracket for each item in that row. This reference points to the outer row. The loop processes each one. It creates a copy while respecting the inner structure. Then it duplicates those inner rows accordingly. That is the core purpose here. We iterate through the outer list, and for every row, we generate a brand new nested list. This achieves a perfect deep copy. But the real advantage is that you can now transform your data in incredible ways. As we discussed, you can now integrate powerful slicing techniques. Take a look at what is happening now. For every row, we are applying a specific slice. Using the 0 to 1 range, what does that do? It means we only copy the very first item from each sublist. Running this gives us a very different result. Here's the original data. And now look at our new safe copy list. It contains only one inner item per outer entry. This gives you immense flexibility. A standard deep copy simply cannot do this. Mastering list comprehension and slicing logic is absolutely vital. Notice how naturally these concepts connect? This journey of discovery is exactly what you should enjoy. This is what true deep learning looks like. This is the power of deep copying. You now understand comprehension and the vital differences between a standard copy and a deep copy. In just a few moments, you are mastering Python in ways you never imagined. Just remember, this logic is not complex. It is just a clean loop within another loop. Simply a nested loop structure combined with straightforward slicing techniques. Nothing more difficult than that. Enjoy the journey ahead. Ever wondered exactly how this code works? Whether you are a Python pro or just starting your journey, let's master the power of the plus operator. We start with a basic list. This one contains our front-end languages, HTML and CSS. Then we have the backend. That includes Python and Django. By creating a new variable and using the plus sign, we can instantly fuse these variables together. It merges them into one unified list, instead of keeping them as separate groups. But here is the clever part. This operation does not just point back to the original items. It does something much better. Python allocates a brand new space in memory to store this combined list independently. You are getting a completely separate, fresh copy. So if we modify the first item of our new list to Java, the original HTML remains totally untouched. Let's see it in action. First, we print the front end, still HTML and CSS. Now, let's check the back end. Is back end still king? You decide. There it is, Python and Django. Finally, look at our full stack developer list. Notice how HTML has been replaced by Java? A bold move for any developer. Yet CSS, Python, and Django are all still there. This proves we created a unique physical list. The plus operator didn't just join them. It generated a clean copy of everything we had. Think of how powerful this is for your projects. Mastering these small details makes you a better coder. If this breakdown helped you understand how memory and operators work, let me know. I would love to hear your thoughts. Remember, this does two vital things. It merges your data perfectly and creates a hard copy to keep your originals safe. That is expert knowledge for your Python toolkit. Don't worry, I'm not here to scare you off. No biting here, just high-value, bite-sized Python insights. Focus up and listen closely. This is a game changer. Well, for your Python life anyway. Let's take a look at the extend method. Let's break down exactly how it works. I have a list right here. It contains the services my company offers. authorization and payments. Now, I'm planning to scale up by adding notifications and analytics. To do that, I want to literally extend my current list. In the code, you'll see I'm targeting the services variable. Those square brackets tell us that this is a list. That's the key identifier. Next, we call the .extend method on that list. This method requires what we call an iterable. In this case, our iterable is our second list, the one containing those new services. We want to merge those directly into our core list, so we pass that second list in as the argument. Now, watch the result. When we run this code, our services list now holds authorization, payments, notifications, and analytics. Our company has officially expanded its toolkit. This is the cleanest way to grow your data. But wait, what about using the plus operator instead? The plus operator also joins two lists together. Imagine you have front-end and back-end services. To create a full stack offering, you might join them into a new variable called stack. It looks successful, but there is a major difference. The plus operator creates a physical copy of the items in a brand new list. It doesn't update the originals. It builds something entirely new. This new stack variable doesn't reference the existing lists at all. It occupies its own fresh space in your computer's memory. Compare that to extend. The extend method actually modifies the original variable. The services list was updated in place, while plus forced us to create a whole new variable to hold the result. In short, extend updates the source, plus creates a copy. Simple yet powerful. I hope that clears up the crucial difference between the extend method and the plus operator. Keep pushing forward on your journey to Python mastery. On your Python journey, you will encounter some very strange syntax. Do you know what this actually means? Don't feel overwhelmed. Giving up now means missing out on one of Python's most powerful tools. Pay close attention because you're going to master this in seconds. Look here, we have a list on the left and a tuple on the right. Variable A is a list. You can tell by those square brackets. Square brackets always signal a list in Python. Now, variable B is a tuple. You can identify a tuple by these parentheses. When you want to join two different data structures, you might assume the plus operator is the way to go. But when we run this, you'll see a frustrating type error pop up on your screen. Python can only combine a list with another list. It won't let you add a tuple. The computer simply refuses to merge these two different types. In this scenario, the standard plus operator just fails. However, if both variables were lists, everything would change. By simply adding square brackets here, the code runs without a single hitch. It executes perfectly. Let's use a print statement to see the final result. There it is, a single merged list. This is exactly what we wanted. Perfect. But let's go back. What happens when you're forced to work with a tuple in a list? You're stuck with that type error again, because the data types don't match. The elegant solution is the unpacking syntax using the asterisk. Watch how this transforms the code. We still use the result variable, but now we wrap the entire expression in square brackets to create a list. We place a star or asterisk right before variable A and another asterisk right before variable B. This tells Python to grab every item one by one and place them into the new list. And yes, this works beautifully for tuples too. It extracts every element from the first collection and then pulls every element from the second. When we run this, look at the output. We have successfully merged a tuple and a list into one clean data structure. We've generated a brand new list containing every single item. Joining different structures now works flawlessly. The plus operator couldn't do that, but unpacking can. That is the magic of the unpacking syntax. It simply means taking items out of one container and placing them into a brand new one. Mastering these small details is what makes you a Python expert. Keep learning one breakthrough at a time. Ever seen this unpacking syntax and wondered what it actually does? It is an absolute game changer for your Python code. While standard methods look familiar, they often hide subtle traps, and those traps cause issues. As we saw earlier, these are separate data structures. Mixing them can lead to endless debugging sessions if you aren't careful. Essentially, you cannot merge two different structures like a list and a tuple using the plus operator. It will simply fail. Python throws a type error because it expects another list, not a tuple. So how do we fix this? We use the unpacking operator, that asterisk symbol before the variables. Here, we have a list and a tuple once again, but watch this, you can actually inject new elements directly into your list with total precision. This lets us slot a 0 right before our first two elements, 1 and 2. Then we can inject the number 99 right before the items in variable b, the 3 and 4. Running this, you'll see we get 0, 1, and 2. The 0 is in place, and 99 has been inserted before variable b. Look at that perfect output. Can you see why unpacking syntax is a superpower for your code? Remember, the plus operator cannot handle different data structures, like the ones we have in variables a and b. It is common to trip up on this, but you don't have to. I'm here to make these concepts crystal clear. You can lean on these easy explanations to master Python quickly. Whenever you see that asterisk next to a variable, it is unpacking that entire collection. It takes every item and inserts them one by one into the new list. And it works for tuples too. Unpacking works for any collection type you might encounter. Whether it is a tuple or a list, the syntax is identical. As long as it is a sequence, it works perfectly. That is why this succeeded while the plus operator failed completely. This is Python by design. Master this syntax for any situation where you need to mix data structures, to create something entirely new.